it is possible, just like in Calc 1, to have infinite limits. That happens when, at a boundary point, if you attempt to substitute values into the function, it yields a non-zero number divided by 0. Okay, so this gets to kind of the one of the fundamental things about calculus, which is that in algebra we always say you cannot divide by 0, and you can't. But in calculus we learn, yes, you can't divide by 0, however, you know where it's going, right? So we know that it's heading to infinity as long as it's a constant divided by that 0. Then we know that while we can't actually find the number per se, we can tell where it's heading. So let's look. If I tried to substitute in, if I try substitution, remember 0 over 0 is a different story. 0 over 0 is a problem, right? That's an indeterminate form. But if I put in the value, I end up with 1 over 1 plus 1 take away 2, which is 1 over 0, which is an infinite limit. Okay, so let's look at this a little bit more in depth. If we think about our domain, we know that x plus y take away 2 cannot be 0, which means x plus y cannot be 2. So we know that's a diagonal line. It looks kind of like this, right? Right there. And so we know that we can have any point aside or in the interior, no problem. And a point like 1, 1 would be right here, right? So that's a problem. That's 1, 1. Okay, so where is it going? Where is it heading towards? So we have to think about if we approach it from this side, right? X and Y would be larger than 2. So we'd have, 5 minus 2. So 1 over 5 minus 2, or 1 over 10 minus 2. So we expect that this side of that boundary line would be x plus y is greater than 2. And over here we expect x plus y is less than 2, because x plus y equals 2 is that line. Okay, now what is that going to mean? So we expect that the limit is going to a positive infinity from above or to the right. Of line x plus y equals 2. And we also expect that our limit is approaching negative infinity, right? Because if we make this, right, but if both of these values are negative over here, right, that'd be quadrant 3, or even if they're just less than 2, we expect this will be going to negative infinity from below / to the left of the line y equals x plus y equals 2. Okay, let's see on a graph in Maple if it bears what we are saying. Okay, so here's the diagonal line. You can see, there it is. And you can also see that that sucker is shooting off. And I do not have this oriented right because my negative is on the left. So here, hold on, I got to orient this another way. 1 second. There we go. Now I've got my orientation correct. So you can see over here to the left, right, we're shooting down towards negative infinity. And over here on the right, we're shooting up towards positive infinity, just like we were thinking. But we can see it visually on the graph if we get it oriented correctly. Right, so there it is. Now let's look at the second example here. Okay, well, x squared plus y squared isn't really a problem, right? Because it's not going to give us division by 0 except at one point. And wouldn't it be the darndest thing, except that is the point we are looking at. So the domain will be x squared plus y squared cannot be equal to 0. And the only way that happens is if xy is 0, 0. Right? Okay, so this might seem like a problem, and it is, right? So our boundary is just this point, right? The origin. And the way we do that is we just put a little ring around the origin, and then we shade everywhere else. There we go. So there's our domain drawn. So let's think. If we tried to substitute, let's see what happens. We end up with 1 over 0 squared plus 0 squared, which is 1 over 0, right? Which is an infinite limit. Okay, now which way is this going to go? X squared plus y squared, because both of them are squared, they're going to always be positive. So we're going to note x squared plus y squared has to be greater than 0. Always. It always has to be positive. It can never be 0 because that would cause division by 0. And it has to be a positive number because both of these are positive numbers. So that means that whatever 1 over whatever it is, it's going to be, we expect the limit is going to infinity, positive infinity. Now let's prove ourselves correct with the maple graph. There it is. Look at it. Look at that thing. It's at 250,000, right? It's huge, right? It's definitely shooting off towards infinity as we head towards the origin. So it's doing exactly what we expect.